The Pyrenees form part of the huge alpine orogenic system. This 430 kilometers long, roughly east-west striking, intracontinental mountain chain divides France, Spain, and Andorra. It has an extended, polycyclic geological evolution dating back to the Precambrian. The chain's present configuration is due to the collision between the microcontinent Iberia and the southwestern promontory of the European plate. The two continents were approaching each other since the onset of the Upper Cretaceous about 100 million years ago and were consequently colliding during the Paleogene 55 to 25 million years ago. After its uplift, the chain experienced intense erosion and isostatic readjustments. A cross-section through the chain shows an asymmetric flower-like structure with steeper dips on the French side. The Pyrenees are not solely the result of compressional forces, but also show an important sinistral shearing. Geographic arrangement. The Pyrenees sensu stricto stretch in a west-northwest east-southeast direction over 430 kilometers from the Bay of Biscay in the west to the Gulf du Lion, and the Gulf de Roses in the east, the width across strike varying between 65 and 150 kilometers. They are bounded in the north by the North Pyrenean Front, a major thrust fault along which units from the North Pyrenean Zone have been transported over the Subterranean Zone, southernmost part of the Aquitaine Basin, the northern foreland. The southern limit is the South Pyrenean Frontal Fault. Here, thrust slices from the Sierras Marginales and the lateral equivalents are displaced southward over the Ebro Basin. Yet in a larger, geologically more meaningful sense, the Pyrenees continue farther west into the Basque and the Cantabrian Mountains. They finally disappear along the continental margin of Asturias. Likewise in the east, they do not just vanish in the Mediterranean but rather pursue the course via the nappy units of the Corbière into Bar-Languedoc and even into southern Provence, at the far eastern end in Provence. Typical Pyrenean fold trends are superimposed by alpine structures to be finally cut off by the arc of the Western Alps. The Pyrenean chain in the larger sense is nearly a 1,000 kilometers long. Structural organization of the orogeny. A profile through the Pyrenees sensu stricto shows a fan-like, flower-like arrangement. The structure is strongly asymmetric with a steeper and narrower French northern side and a much wider and more gently inclined Spanish southern side. The double-sided orogeny can be divided into several tectonic zones, from north to south, that are bounded by east-west trending major faults. Northern Foreland, Aquitaine Basin. Subterranean Zone, a Subterranean Basin. North Pyrenean Zone, Axial Zone. South Pyrenean Zone, Sierras Marginales. Southern Foreland, Ebro Basin. Along strike, the Pyrenean orogeny can be split into three distinct domains. An eastern domain reaching from the Mediterranean to the Segre River, a central domain extending from the Segre River to the Pamplona Fault, and a western domain beyond the Pamplona Fault. Northern Foreland Subterranean Zone. The Subterranean Zone is geologically part of the Aquitaine Basin, the northern foreland of the Pyrenees, and was caught up in the Pyrenean orogeny. The zone was folded during the Eocene and overthrust en echelon by the North Pyrenean Zone along the North Pyrenean Front. These upthrusts changed the character in the west and in the east of the orogeny, where they become nappy-like. Examples being the Barra-Dou nappy in the west and the Corbière nappy in the east. The latter continues farther east via folds and tectonic slices near Saint-Chinian, via the fold near Montpellier to join the South Provence thrust near Saint-Baume, which gradually disappears south of Brignoles. Within the Pyrenees sensu stricto, the Subterranean Zone consists of Upper Cretaceous and very thick Paleogene sediments in surface outcrops. The sediments show simple folds following a WNWESE trend. The subsurface, however, has a far more complicated structure due to Triassic salt diapirs and North Virgin thrusts. Hidden below are more than 6,000 meters thick Mesozoic cover are probably more than 6,000 meters of Paleozoic basement rocks. The Mesozoic cover consists of up to 1,500 meters of Triassic, well over 500 meters of Jurassic and more than 3,000 meters of Cretaceous sediments. The up to 500 meters thick layer of lower Triassic comprises conglomerates, breccia, brown sandstones, argillites, shales, and siltstones. The middle Triassic can attain a thickness of 400 meters and shows silty shales, evaporite deposits, and dolomitic micrites. The up to 500 meters thick upper Triassic coipa deposits are made up of carbonate-rich sediments, salt, siltstones, and intercalated ophitic diabases, olivine dolerites. The Laulias is a transgressive sequence with up to 200 meters of non-marine sandstone, near-shore marine limestone and evaporites. A pelagic fauna at the top suggests open marine conditions. The middle and upper layers consist of 230 meters of shallow marine platform sediments. During the Middle Jurassic, an oolitic barrier, made up mostly of argillaceous micrites, separates an outer shelf from an inner shelf. The Upper Jurassic deposits are mainly shales and carbonates. Near the end of the Jurassic, restricted environments were established with dolomicrites, banded limestones, and evaporites. The Lower Cretaceous layer starts with sandstones, shales, limestones, and calcareous breccia in the Neocomian, followed by Barremian marls and limestones. During the Lower Aptian, sandstones, shales, sandy marls, and limestones were laid down. The Upper Aptian and the Albian are mainly marls and limestones. The Upper Cretaceous includes a littoral Turonian with sandstones and sandy limestones. By the beginning of the Sinonian, a deep trough had formed receiving a very thick flysch sequence. The Campanian and Maastrichtian flyschs comprised 2,000 to 3,000 meters of periodically interlayered fines and coarser sediments. Near the K-T boundary, the Subterranean basin was filled with continental red deposits and Garamnian faces, even including dinosaur eggs in a few places. At this point, the Subterranean basin underwent folding accompanied by a weak metamorphism. Above the Albian and before the onset of the Campanian, volcanic rocks occur including basaltic lavas, spilite, and diabase, but also pyroclastic rocks like tuff, lapilli tuff, volcanic breccia, and agglomerate. The volcanic rocks can be cross-cut by lamprey fire dikes. In Paleocene, Eocene times, the sea transgressed from the Atlantic into the Subterranean basin, which behaved as a downward to the slowly rising Pyrenees immediately to the south. A very thick succession of fine-grained detritallic calcareous sediments was deposited. The sedimentation stopped in the late Eocene due to major compression. In the vicinity of the Muret Fault, a left lateral strike-slip fault in a prolongation of the Toulouse Fault to the south. The Subterranean Zone can be divided into two unequal halves. The eastern half between the rivers Garonne and Aude can be separated into three different zones: a northern foreland, a 10 kilometers wide folded zone. Its northern boundary are the ranges of the Petite Pyrenees, which are above a blind thrust. This zone narrows to the east and disappears before reaching the Aude. The sediments comprise a gypsum-bearing Triassic at the bottom, followed by an internally thrusted Jurassic and a very thick cover sequence of Upper Cretaceous flysch sediments. A narrow band of flysch in the south. This fairly thick flysch sequence was also deposited in the Upper Cretaceous. It was upturned into a nearly upright position by thrusting movements on the North Pyrenean front and now forms the overturned southern flank of an asymmetric syncline. In the western half, only the northern foreland is present. It is made up of gently folded, but strongly jointed, epicontinental Mesozoic sediments covered and hidden by Miocene molasse sediments. The east-west and northwest-southeast striking fold sets interfere and are cut by northeast trending faults. In the subsurface, Triassic salt diapirs are also present. Within the northern foreland east of the River Ord, the Paleozoic basement uplift of the Maudaume appears. A horse tilted to the south and covered by continental Eocene strata. The fold trains of the Subterranean Zone are disrupted in the Bar-Languedoc by the Sievener fault, a major left lateral strike-slip fault. North Pyrenean Zone. The North Pyrenean Zone is quite narrow, usually only about 10 kilometers wide, but can widen to 40 kilometers. It is characterized by a very strong folding. The zone is thrust to the north along the North Pyrenean front, its northern limit, over the Subterranean Zone. This thrusting motion compressed the overthrust foreland and as a result induced folding in the Subterranean Zone. The North Pyrenean Zone is itself overthrust by the Axial Zone along the North Pyrenean Fault, a high-angle reverse fault forming its southern boundary. The North Pyrenean Fault is marked by highly strained mylonites. The rocks in the vicinity bear horizontal lineations underlining the importance of the fault as a major shear zone. Elsewhere in the North Pyrenean Zone, the strain gradient is also high, but the stretching direction is generally vertical. The more than 6,000 meters thick sedimentary package of the North Pyrenean Zone is formed by Mesozoic rocks that have been detached above Upper Triassic, evaporites and subsequently slid to the north. In contrast with the Subterranean Zone, the North Pyrenean Zone contains hardly any Paleogene, Upper Triassic shale and evaporite deposits locally contain interbedded dollostones, tuffs, and diabase. These deposits behave plastically and commonly form a tectonic melange, with contacts being expressed as décollement surfaces. For the beginning of the Jurassic till the end of the Lower Cretaceous, a shallow water carbonate platform developed during tectonic quiescence, with mainly limestones being sedimented. The Middle Albian witnessed a major phases change to deep marine conditions. This changeover marks the inception of the North Pyrenean Basin, a 400 kilometers long trough of pull-apart origin filled with unconformable, turbiditic flysch sediments during the Upper Cretaceous. By Upper Albian times, this pull-apart basin had split into an internal trough next to the North Pyrenean Fault, which accommodated the flysch ardoisier, and an external trough farther north filled by the flysch loire. Later, during the Turonian and the Coniacian, the external flysch trough received the so-called flysch fucoids, a very thick succession of interbedded calcareous mudstones, milestones and sandy calcareanites. This flysch is followed by a regressive series in the Maastrichtian, thick marls, platform limestones, as well as lagoonal and lacustrine deposits. Altogether, the Coniacian Maastrichtian series reaches a thickness of 3,000 meters. The Paleozoic basement pierces the sedimentary cover in several almond-shaped, horse-like uplifts, the size ranging from 1 to 300 square kilometers. Examples of the so-called massif satellites Nord Pyrenees between Lourdes and Perpignan. Amongst them the following uplifts: Ali, Arise, Barus, Bessadosu, Castellon, Millers, Plantuch, St. Barthélemy, Salvezines, and Rabat, Les Trois Seigneurs, plus several uplifts in the northern Basque country. These uplifts have a left lateral shearing origin and are tilted to the north. Simultaneously, they also exhibit a vertical shearing component. They probably formed in the Variscan orogeny. In the basement uplifts, mainly Precambrian gneisses and granulitic gneisses, and Paleozoic igneous and metamorphic rocks are found. A small, maximally 5 km wide strip just north of the North Pyrenean Fault experienced dynamic and thermal metamorphism during the Albian Cenomanian about 110 million years ago. Some domains north of the basement uplifts were also metamorphosed. The metamorphism was isochemical without introduction of extraneous elements and affected only the sedimentary cover rocks, which were transformed into marble and hornfalls. The Paleozoic basement was not affected, probably due to its already dehydrated state. Scattered within the metamorphic strip are several occurrences of liozolites. They were extruded from the upper mantle along deep-reaching faults. The liozolites are associated with amphibolites, pyroxenites, and amphibole-bearing peridotites. All these mantle rocks are arranged in swarms, the biggest outcrop at Moncop reaching a mere 3 square kilometers. They are widely distributed, being found from Beaqtarn all the way to Oud. Their emplacement mode has not been clarified yet, but the following factors are relevant. Associated Jurassic and Lower Cretaceous marbles of the metamorphic band. Granulites of the basement uplifts in the vicinity, migmatitic kinsergites. The close spatial association with the North Pyrenean Fault a bit farther south. Liozolite sedimentary clasts occur in marbles of the metamorphic strip, so the liozolites must be older than the metamorphism. Scattered within the North Pyrenean Zone are also some occurrences of volcanic rocks. They are intercalated in sediments of the Lias and the Upper Cretaceous and are found mainly in the west. They consist of silica undersaturated spilites, picrites, and nepheline cyanites. Associated dike rocks are lamprifiers. Other features of interest are several different post-metamorphic breccia formations. The North Pyrenean Zone can be subdivided into 3 subzones bounded by major faults. A northern subzone. Its sedimentary cover has detached from the basement uplifts farther south. It contains flysch from the Upper Cretaceous, an intermediate subzone. Here the basement uplifts crop out. A southern subzone. It was affected by metamorphism and contains outcrops of ultramafic rocks. The North Pyrenean Zone is traversed in the west by NNESSW trending left lateral strike-slip faults and then changes into the fold belt of the Basque Country. In the east, it continues after a sharp bend in the Corbière right into southern Provence. At the far eastern end, northwest-southeast striking Miocene fold trains of the Western Alps start interfering and finally completely overwhelm the Pyrenean structures. Axial Zone. The Axial Zone, also called Primary Axial Zone, is a huge basement dome of Precambrian and Paleozoic rocks folded and metamorphosed during the Variscan orogeny and intruded by late-stage Variscan granitoids. All the highest peaks of the Pyrenees are in the Axial Zone, hence the name. Amongst the Variscan granitoids are biotite granites, 2 microgranites and granodiorites. The granitoids are mainly shallow epizonal intrusives, but mesozonal and catazonal rocks are also represented. The high elevations of the axial zone are compensated isostatically by an increased thickness of the continental crust. For instance, below the Maladeta Massif, a root zone formed so that the Mohorovičić discontinuity is encountered there at a depth of 50 kilometers. Likewise, over most peaks of the axial zone, a negative gravity anomaly can be detected which slowly disappears to the east. The basement is traversed by major east-west striking, late Variscan fracture zones that were reactivated during the alpine orogeny cycle. In the eastern part of the axial zone, the fractures are generally upright, a good example being the Mylonitic Merens fault at Pic del Portvel near Merens les Vals. In the western part, the fractures are more gently dipping to the north and behave as en-echelon thrusts arranged in a northwest-southeasterly fashion along these fractures. The basement of the axial zone overthrusts Mesozoic sedimentary units to the south. Good examples of the en-echelon thrusts at Oshos, Gavarni and Benasque, Las Nogueras. Concomitant with the thrusts, a schistosity developed that affected the basement as well as the sedimentary cover, implying an alpine origin. All these fractures account for an overall compression of the axial zone by 20%, which translates as roughly 10 to 20 kilometers of crustal shortening. As a result, the axial zone was squeezed into a south-directed antiformal stack. The axial zone disappears in the Obeaqtarn as a pericline underneath the upper Cretaceous sedimentary cover, only to reappear in the basement. Uplifts of Alda de Quinto are Eaqtal, the southernmost of the Basque basement massifs. In the east, the axial zone becomes downfaulted into Neogene and Quaternary grabens of northern Catalonia and finally disappears underneath the Mediterranean. The central and eastern section of the axial zone is bounded in the north by the North Pyrenean Fault, a system of N110 striking, steeply dipping reverse faults. The trace of the North Pyrenean Fault becomes more and more diffuse west of Lourdes, near the Basque basement massifs. It seems to be displaced to the south by a wrench fault and then possibly continues into Spain south of the Basque Marble Nappe and south of the Basque Fold Belt in Cantabria. It finally reaches the Atlantic coast. The southern limit of the axial zone runs completely on Spanish territory. It is represented by an alpine reverse fault along which the sediments of the South Pyrenean Zone are overthrust by the axial zone. In the east, the axial zone abuts directly against nappes of eastern representatives of the Sierras Marginales. South Pyrenean Zone. The South Pyrenean Zone consists of a Mesozoic-Eocene sedimentary sequence which has detached from the axial zone within evaporitic horizons of the Middle or Upper Triassic and consequently was transported southward. The basement of this sequence does not outcrop. The southward motion was channelized by two major conjugated faults. In the west by the more or less north-south trending folds and thrusts near the Cinca River, and in the east by the northeast-southwest trending en-echelon wrench faults at the Segura River. At the latter, the thrust system forms a breakback umbricate emergent fan which developed during the latest Eocene and early Oligocene. Due to constriction, the sedimentary cover was forced into several internal overthrusts, examples being the nappe of the Monte Perdido and the nappe of the Coachella in the northwest. More centrally placed is the Boyles thrust sheet, which continues farther east in the Pedraforca thrust sheet. The Boyles thrust sheet is hindward thrusting but also overrides the Monsec thrust sheet to the south. Its sediments reach 5,000 meters in thickness and are mostly lower Cretaceous in age. The Monsec thrust sheet correlates with the lower unit of the Pedraforca thrust sheet. It consists of a 2,000 meters thick layer of Upper Cretaceous limestone followed by Lower and Middle Eocene syntectonic conglomerate, sandstone and shale. The internal thrusts naturally led to a substantial increase in thickness. The South Pyrenean Zone finally terminates along the South Pyrenean thrust where the Montsec thrust sheet overrides the Sierras marginales. The thrusting motions that formed an imbricate thrust system with associated piggyback basins took place mainly during the Eocene. The distances traveled by the thrust sheets is still debated, estimates varying from relatively small to as much as 30 to 50 kilometers. Sierras marginales. The Sierras marginales of the Sierras Aragonenses and Serres Catalanes of the southern Pre-Pyrenees. They are, much like the South Pyrenean Zone, formed from a Mesozoic-Eocene sedimentary succession, albeit with a much reduced thickness of about 900 meters. The succession comprises Kuiper, Jurassic, unconformable Lower Cretaceous bauxites, unconformable Upper Cretaceous, Paleocene and Garamian facies, and Lower Eocene units of the Sierras marginales under thrust successions of the Ebro Basin. Later on, these under thrusts were unconformably covered by Oligocene and Miocene sequences from the Ebro Basin. To the west, the Sierras marginales are relayed by the Jaca-Pamplona thrust sheet, which consists of a younger Eocene-Oligocene sedimentary succession. In this thrust sheet west of the Gallego River, the structures simplify. In the Basque and in the Cantabrian Pyrenees, the sedimentary cover is affected only by long and relatively opened fold trains, which are occasionally pierced by doming Coip basalt. In the east, the Sierras marginales are represented by the tectonically comparable Port del Comte thrust sheet and by the Cardi thrust sheet, which are made up essentially of an Eocene succession. The Sierras marginales are overthrust in the north by the Montsec thrust sheet of the South Pyrenean Zone. The end of the southward directed thrusting motions was diachronous and migrated from east to west. For instance, in the Cardi thrust sheet, motions stopped 34 million years ago, whereas in the Jaca-Pamplona thrust sheet they stopped as late as 23 million years ago. Southern foreland. The southern foreland of the Pyrenean orogen is the Ebro Basin or Ebro Foreland Basin. It can be divided into a southern folded foreland section in the northeastern Catalonian sector and a basically undeformed flat-lying main section, taking up the rest, like the Subterranean Zone in the north. The southern folded foreland was also affected by the thrusting motions of the Sierras marginales and their easterly representatives. The induced folding intensity decreases the farther one moves away from the thrust fronts until one reaches the undeformed Ebro Basin. The fold trends follow more or less the Pyrenean direction are parallel to the thrust fronts, but turn SW near the Segre River. The sedimentary succession in the Ebro Basin shows Paleozoic rocks at the base followed by uppermost Cretaceous, lowermost Paleocene red beds and Eocene limestones, marine marls, and upper Eocene evaporites. The lower Oligocene is conglomeratic and progrades southward into evaporite and lacustrine deposits. In the southern folded foreland, the folded Paleogene series are unconformably overlain by flat-lying non-marine Miocene and Pliocene strata of the main Ebro Basin. The Ebro Basin deepens towards the South Pyrenean frontal fault where it comprises 3,000 meters of sedimentary infill. This reduces to 1,500 meters near the thrust front of the Sierra marginales, the deepest part of the basin with 5,000 meters of sediments is near Logroño at its most northwestern end.